So this is section P2, functions. So we're going to introduce functions. We're going to talk about some pitfalls that a lot of people fall into, and just give a basic introduction to what a function is. So if we boil it down to the basics, a function is a machine that you put something in and you get something out. All right. So oftentimes what we'll be putting in to the machine are numbers, and we'll be getting out numbers. All right. What the machine does is it manipulates the input and gives you an output. All right. We'll be calling a lot of our functions f, but many different letters, f, g, h. We use them all for denoting functions. All right. The numbers we put in, 1, 2, 3, 1/2, whatever, oftentimes we generically call them x. All right. And the output is going to be the number that we call f of x. This is purely notation. Okay. So one thing I think a lot of people kind of get confused with is they see these parentheses here, and parentheses are often used with multiplication, right? So 3 times 5, you can write that as 3 parentheses 5 like this, right? Well, these parentheses here do mean multiplication, but the parentheses for the f of x notation do not have anything to do with multiplication. It's purely notation. And this notation here, this f of x notation, is just saying if you put the input x into our machine, then the output will be what's called f of x. All right? So input x, output, the name of the output is f of x. All right? You can kind of think of it that way. Okay, so it seems very general, a very general description. You put something in, you get something out, and it is. But there's one rule that we have to have for a legal function. Given input, so given an input, there can only be one output. Okay, so you cannot have one input, so you put one input into the machine, you cannot have two things pop out, all right? You cannot have any ambiguity as to what comes out, right? You put something in, you're gonna get something out, you're only gonna get one thing out, all right? Okay, so that's essentially the only rule that we have to have when we work with functions. Because if you allow a function to spit out more than one thing, then there's always this ambiguity. Is it spitting out the first thing today? Is it spitting out the second thing tomorrow? Right? It's not very difficult to work with things in that way. So whenever you put something in, you only get one thing out for sure, that one thing. Okay? So an example, a very simple example, f of x equals x plus 1 squared. When we write this, right, this is instructions for the function. This left-hand side is the output, right, as we said, output of the machine f. And this instructions on the right-hand side is how to get that output, right? So for example, if I write f of 1, that would mean the output that I get when I put in the input 1, right? So I have my machine f, I'm putting in the input 1. What is the output that I get out? Well, this right-hand side here gives me the literal instructions. So the instructions is whatever I put in, I add 1 to it. So I'm putting in 1, I add 1 to it, and then I square that result. Okay, so this is going to be 2 squared, which is 4. So when I put 1 into my machine, into this particular machine, I'm going to get the output 4. All right. Okay, and one thing you want to do is you want to be very careful about following the instructions. So if I put in the number 2 into my machine, right, what is the output? Well, again, if I read this in words, this instructions for this particular function in words, whatever I put in, this guy right there, I should add it to 1 and then square the result, right? So whatever I put in, 2, I should add it to 1 and then I square the result. So that's going to be 3 squared, which is 9. Okay. Now, so this guy here is 9. So that might seem kind of silly and obvious, but for numbers here, it might be, right? It might be kind of obvious what I just did, but very soon we'll be working with very complicated inputs. So, for example, one small kind of complication is I'm not going to be putting in a number, I'm going to be putting in a letter, right? T. But you just follow the instructions, right? Whatever you put in, T, add 1 to it, and then square it. So whatever I put in, which is the T, add 1 to it, and square it. Okay? Maybe that one's not too bad. So let's talk about this. F of x plus 7, right? So this gives people a lot of trouble. But still, you just follow the instructions, and it's probably, again, a good idea to read the instructions in words, right? So for this particular function, the instructions are whatever I put in, add 1 to it, and square it. So I'm putting in x plus 7. So I have x plus 7, I add 1 to it, and then I square that. Okay? So ultimately, this guy here is x plus 8 squared. All right? So the fact that we're using an x here and we're using an x up there, these two x's are actually not related to each other, right? So this x up here is just a kind of placeholder to represent the thing that you put in, all right? And so that, it's used so that we can actually describe the procedure for calculating the function. Whereas this x down here kind of helps us represent what actual value we're putting in, all right? So one way you can think of this is I write my instructions up here as f of x equals x plus 1 squared, but I could easily have just written f of box equals box plus 1 squared. That's an alternate way to describe the same function, right? Because the description is still whatever I put in, add 1 to it, right? And then square that result. Okay? So if you think you might actually get confused between, f of x equals x plus 1 squared and then calculating f of x plus 7, maybe you could do an intermediate step where you get rid of the x's in the description of the function. And you write it literally maybe something like this: f of box is equal to box plus 1 squared. And then maybe there's less chance of confusion when you go about calculating f of x plus 7, because the x plus 7 just replaces the box, and you don't have this two x's in two different locations actually meaning different things in a way. All right. Okay, and we can continue this as complex as we like, right? So f of x squared would be, well, you just follow the instructions. Whatever you put in, add 1 to it. I'm putting in x squared, so x squared, add 1 to it, and then square the result. All right, again, this may seem very simple, but a lot of people have trouble with this, so you definitely want to make sure you're comfortable with how to plug things into functions. All right, a couple other pitfalls. So one thing that is that we often write with functions, up here we actually did it, right? We had f of x plus 7, right? F of something plus something else. So if you do have f of something plus something else, let me say f of x plus y, right? What is that equal to? Can I simplify this? One thing that a lot of people think that you could do is you can simplify this as f of x plus f of y, all right? But this is not true, okay? One reason why you might think that this is true is because, again, you're thinking of these parentheses as kind of multiplication. And if you do see something like 3 times 5 plus 7, right, that is actually equal to 3 times 5 plus 3 times 7. And in a way, right, if you use this, if you look at this function here, you can kind of maybe think of this f as the 3. And so perhaps you think it's reasonable that f of x plus y is equal to f of x plus f of y. All right. But again, this doesn't work because these parentheses here do not represent multiplication, right? They're merely symbolic. And in fact, maybe in an alternate universe, people don't use parentheses to indicate functions like this. Maybe they use brackets, right? F of x plus y. And then people wouldn't have this kind of confusion because they wouldn't be confused thinking about parentheses and stuff like that. Okay, so this parentheses here merely is notation, does not indicate multiplication. And so when you're, I shouldn't have done that. So when you're calculating with functions, don't kind of pull things in and out of the parentheses, these two parentheses here, unless you have explicitly a rule that tells you you're allowed to do it. All right. So this is also true for products. So if I look at f of x times y, that's definitely not equal to, for example, let's say f of x times f of y, right? It's definitely not equal to x f of y. It's not equal to f of x times y. All right. Never, ever, ever move things inside parentheses outside of parentheses. Okay. Unless you have a specific rule that tells you you're allowed to do it for that particular function. Okay. So in particular, something like this, f of 3x, that's definitely not equal to 3f of x. All right. F of 3 plus 5 is definitely not equal to f of 3 plus f of 5. All right. So you definitely want to make not make this kind of mistake because we're going to be working with functions a lot in this class. In fact, the next week is going to be trig functions. And so if you're making these kinds of mistakes with the functions, you're going to get a lot of calculations wrong with trig functions. Okay, again, you absolutely, if you are going to be moving stuff in and out of parentheses, right? So here, what I mean is I have this 3 inside the parentheses. I have the 5 inside the parentheses, right? Somehow here in this, on the right-hand side, I've moved the 3 and the 5 to their own parentheses like that, right? Not allowed, okay? This 3 is inside the parentheses here of the f, and here on the right-hand side, it's outside, not allowed, okay? Unless, again, explicitly you have some rule that tells you how to do it, or tells you that you can do it, maybe. So, in fact, we'll see next week when we work with the function f of x equals sine of x. What is f of x plus y, right? That would be equal to, again, if I just follow the instructions, right? Whatever I put in, take sine of it. So this is sine of x plus y, all right? And many, many people will be tempted to say in the next line that this is sine x plus sine y. And that's literally doing this mistake up here. Same as doing this mistake up here. Okay, and it's absolutely not true. All right. In fact, we're going to spend an entire section, several sections in this class figuring out exactly how to simplify this guy here, how to kind of break up or pull the x's and the y's out of the parentheses, and it's definitely not going to be this guy here. In fact, it's very complicated. It's actually cosine of x, sine of y, plus cosine of y, sine of x. So here's a good illustration that dealing with these parentheses here, right, kind of pulling the x and y's out of the parentheses can be extremely complex, right? You actually end up, in fact, popping out cosines when your original function was a sine, okay? So this mistake here is really, really bad, and you want to definitely avoid it at all costs. All right, because almost for no functions is this property true. All right, only for the most simplest of functions is a property like this true. Okay. All right, another example that people often kind of have trouble with, f of x equals 1 over x. All right, so what is f of let's say 3 plus 5, right? So a lot of people are tempted, right, again, to say this is f of 3 plus f of 5, right? But we can actually check this. What is f of 3 plus 5? That's f of 8. And in this particular example, the instruction says whatever you put in, take 1 over it. I'm putting in 8, so the instruction says this should be 1/8. All right. On the other hand, on the right-hand side, this guy here, I'm putting in 3, so my output should be 1/3. Right? Here, I'm putting in 5, so the output should be 1/5. And so the right-hand side should be equal to 1/3 plus 1/5. Okay? And if I put common denominators here, I'm going to get 15. And on the right-hand side, I'm going to get 8. All right? Okay? And you can see these two guys are definitely not the same. Right? In fact, 8 over 15 is bigger than a half, and 1/8 is much smaller than a half. So definitely, again, this guy here is not equal. All right? And once again, the property where you can do this only works for really, really simple functions. All right, another situation where we see this a lot is if you have f of x equals square root of x, right? Then what is f of x plus y, right? That's going to be, just by the definition, whatever I put in, take the square root of it. I'm putting in x plus y, so this output should be square root of x plus y. Okay. Now, a lot of people will say, okay, square root of x plus y, that's equal to square root x plus square root y, right? In effect, right, what is square root x? That's f of x. What's square root y? That's f of y, right? So if you do this step from here to here, right, you can see that that's in effect saying that f of x plus y for this function is equal to f of x plus f of y, right? But again, in general, it's not true. And in this particular case, it's also not true. So you cannot do this, all right? Let's see, another very common one, f of x equals x squared, right? So what is f of, let's say, 3 plus 5? Let's do this one numerically, right? That's 3 plus 5 squared, right? Whatever you put in, square it. That's the instructions for this guy. Okay, now a lot of people will say, okay, I have a square here, so that means 3 squared plus 5 squared, right? But again, if you think about this, what is 3 squared? That's f of 3, right? So this is equal to f of 3. What's 5 squared? That's f of 5. So if you do this step from here to here, you're implicitly saying that f of 3 plus 5 is equal to f of 3 plus f of 5. And again, we know that this big step from here all the way to there is generally not true. And so we suspect that there's a mistake going from here to here. And in fact, there is a mistake. This is absolutely not true. Okay? And you know this because, well, if we just calculate, 3 plus 5 is 8. 8 squared is 64. Whereas 3 squared down here is 9. 5 squared is 25. 25 plus 9 is 34. 34 is definitely not equal to 64. Okay? So when you do this step, you're missing the cross terms because 3 plus 5 squared is 3 plus 5 times 3 plus 5. And so if you actually want to do it carefully, it's 3 plus 3 times that, 3 times that, 5 times that, 5 times that, right? So you do have the 3 squared term, which is this one. You have the 5 squared term, which is this one. And that gives you this guy and this guy down here. But you're missing the 2 cross terms, the 3 times 5 and the 5 times 3. Okay. So that's a really common mistake that people do. And again, that mistake, this mistake right here, is in effect doing this mistake over here, which again, we know is generally very, very false. Okay, in the same way, I focused on kind of addition here, but it's also true for multiplication in general, right? So this is not equal to f of x times f of y in general, right? But there actually are some examples where it does work. So if I look at f of x equals square root of x, right? Then f of xy is equal to square root of Well, again, what are the instructions? Whatever you put in, square root it. I'm putting in xy, so square root xy. Okay. Now we know from the properties of square roots, actually from the first lecture in this Math 92, that this is actually equal to square root x times square root y. So this one is actually true, right? We saw that last week. And this indeed, square root x is f of x, and square root y is f of y. So this happens to be true in this example, okay? So there actually are, maybe kind of just with the functions that we play with a lot, there's more examples of this guy working than with the addition situation working. But still, in general, it's not true. Okay. In particular, again, we're working with trig functions in our class. Sine of xy is definitely not equal to sine of x times sine of y. Okay. And in fact, there isn't really a nice formula that we're going to talk about that does kind of allow us to break this guy up. All right, another example of this situation where multiplication does work, right, is, for example, f of x equals x squared, right? Then f of x times y is equal to whatever I put in. The instructions for this function says whatever I put in, I should square it. So whatever I put in, I'm putting in xy, I should square it, okay? Now the properties of powers tells me this is x squared times y squared, so this is actually true, which happens to be f of x times f of y. So this is another kind of exception to the rule that generally you cannot do this. All right. So be very, very careful about when you're allowed to do something like this and when you're not allowed to do something like this. Right. So maybe something for you to think about, if I have f of x equals 1 over x, right, is f of xy, equal to f of x times f of y. All right, does it work for this particular example? Right. And let's do one more. F of x equals x plus 1 squared is f of xy equal to f of x times f of y. Okay. All right, so that's the very, very basics of functions. One thing that we'll be doing a lot, and that we've seen in this lecture here, is we often write functions using the variable x. So for example, f of x equals x squared. But again, we've already kind of mentioned this. The x is, it doesn't really matter what letter I use. So sometimes we'll be using t to describe functions. And these two are the same functions, okay? Because their description is the same. The first one is whatever I put in, square it. The second one is whatever I put in, square it. So they're actually the same, all right? But, you know, we'll often use t's, for example, when we're doing examples or doing problems that involve time, right? So maybe our function represents something happening at different times. So then we'll want to use t, okay? So you definitely want to be comfortable with working with functions where they're described in kind of ways other than x, right? So f of a equals a squared. This is the same function, right? And as we said, right, even f of box equals box squared is the same function. Okay, all of these guys are the same functions, just given in different descriptions. And we generally kind of like to describe them in terms of x, but there is no requirement for that. All right, so that's section P2. We wanted to talk about this because this week, because next week we're going to be starting to work with the trig functions.